Hello, welcome to the second part of the discussion of this image cartoonify app. I believe you already have seen the first part where we discuss about all the functionalities of this app. You can still watch that video by clicking this button. In this video, we'll be discussing about the development part and deployment part of this application. So let's start with the front end part. So as you can see, this front end is completely developed with the Streamlit app. Streamlit is super easy when it comes to development of the front end, especially for the machine learning project. Yeah, you don't have to, you don't need any knowledge about the CSS and JavaScript things. With just Python, we can develop this kind of interactive front-end, and it also provides the functionality of creating multi-page site where we can create this kind of multiple pages and can display different content on each page. And the main thing is it don't provide the different endpoints like the other sites have for the different pages. As you can see here, from the single endpoint we get the multiple pages, so it manages everything virtually only. And yeah, if I change any button or anything on any particular page, then all the codes of that particular page will rerun again. That's the disadvantage of Streamlit, but you can counter it by using caching mechanism. So I've used caching whenever it was possible, but we are using the TensorFlow model for this generating cartoon image, so it's not possible to cache the model loading part because it was throwing some weird error. So due to that, on each request it will load the model every time, but main thing is it takes only around 0.2 to 0.3 seconds to load the model, so it's currently negligible. And also model it takes very short time, and also the predictions are running on the CPU only, as this app is currently hosted on Heroku cloud. We get only CPUs over there. So that will discuss in deployment part. So yes, as I said, in backend the images are generated with the TensorFlow model. It uses one TensorFlow 1.x, and the predictions are made on the CPUs only. So that's why it takes longer time on generating predictions. I've tested this code on GPU devices, and in very short time I am getting the responses. So inference time is less on GPU compared to CPU. And so for this page there is only one functionality. By selecting image, it will pass on to TensorFlow model, and model will generate the cartoon image. So this gallery page is a static page. It just displays the images, and credit page is a static page. But here the for nerd page, it is actually completely a dynamic page, because everything here we are seeing is coming from the database. So this app is using postgres SQL database. On each request, there will be an insert query will be fired for this much column with the respected values, and on this on the loading of this page, it will fire the select query, and it will pull all the records from the database, and it displays here. And the inference time and everything here we are seeing is this statistics of minimax and average is also computed from the considering all the records from the database. So whenever uh, if you re- if you call a new request, then this will have another row, and all the numbers will be different on each request. And this pie chart is also generated dynamically from the this table itself. So it mainly focuses on this input type part. So how much percentage of requests are of image type and then not image type. As some user like to test it as a they provide the some another files which is not an image file to the model. So it just returns the not image uh, label, and will not have shape for it, and inference time will also be 0 for that request. Otherwise it will return the shape and the inference time is 2. So as you can see, these two requests have same shape but time is different. So again, a network latency plays a role in this. And another plot is of a bar chart which displays the day-wise request count. So on the x-axis we have dates. So as currently I've hosted this app yesterday on Heroku Cloud, so I have only 2 dates here. But whenever you are seeing, you might have more number of bar here, definitely. And on the y-axis we have count of the request. So yeah, the request count will not be in a float. It will be always integer, but it dynamically sets the axis. So yeah, this so as I said, this entire page is generated dynamically on each and every request. All the details, all the numbers, and both of the plots will be updated. Yeah, so I think that's the major part in development purpose. So in deployment, as I said, this app is hosted on Heroku Cloud. It is using the free tier of the Heroku Cloud. So as Heroku provides the 500 hours of uptime for the app per month. So that means out for the 500 hours only for each and every month. After that, it will show the error message that you have exhausted the current month limit. And yes, if this app is inactive for 45 minutes, then it will go to sleep mode. And again, when the new request comes, it will again load the entire image. And yes, the in the free tier we get the 500 MB of the storage space, which means whenever we host our app on Heroku Cloud, it will create the virtual machine over there, and it will install all the requirements, the Python requirements which application needs. So as this app has a TensorFlow and very big libraries, so it has occupied around 310 MBs out of 500. So I was getting the warning of oversize, because in Heroku they have some limit of 300 MB. So if my app is more than 300 MB, then there was a warning that it might affect the booting time of this application. So if you experience any higher booting time, then that's the reason for it. And yes, this table is generated dynamically from the postgres SQL database. So database is also used from the Heroku only. Heroku provides the postgres database. So we need to just create one database, and we have to use the credentials and have all the details in our application. Yes, in the free tier we get the in the heroku we get the database with the capacity of 10,000 rows. So as you can see, currently it's as a 25. So it started with 0, so we have 26 rows. So this in free tier we can get up to 10,000 rows of data stored in the postgres database. After that, it might override the database, or it will not allow to insert new records. I don't know. I have not reached to that limit yet. Yeah, so I think that's the uh, deployment part. It was very straightforward to deploy the application on Heroku. All the details are available on their site, as well as uh, many members of community have developed the tutorials and videos on how to deploy the site on Heroku. If you have any doubts, you can reach out to me via LinkedIn, or you can send me an email on this email address. I will definitely try to reply as soon as possible. Thank you for your time. Bye.